Then let's proceed to atoms, molecules, and ions. So if you played, familiarize the periodic table. So here class is the period and these are the groups. So these are arranged based on the number of proton. Okay, so in this group 1, we have alkali metals. So hydrogen is not included in the name because this one is a non-metal. Then for group 2, we have alkali earth metals. And in the middle class, this one is called transition metals. And for here, we have the boron group, the carbon group, the pictogens group, and then chalcogens, and then the halogens. And the last one, the most stable one, is the noble gases. So, fun fact, why it is called noble gases, because they're king and queen of the periodic table. So, they don't bond with other elements. So, that is why they are noble gases. Okay. Now that we know the different groups and the period, so the period is the row and the group is the column. So now that we know our periodic table, let's go and discuss the atom. As we know, element is made up of atoms, and this atoms class is the smallest unit of matter. And this has 3 subatomic particles. So which is proton, which has a positive charge, and the neutron, which is the neutral charge, and the electron, which is the negative charge. So let's see how these subatomic particles was discovered by the different scientists. Okay, so we know in our previous lesson that J.J. Thomson discovered the electron through his cathode ray experiment. So as we know in this light, in this ray, you can observe that there is a repulsion that is happening. So he concluded that this repulsion happens because there is a negative charge inside of this ray or this. So, which he discovered the electron. However, he also formulated an equation to know the mass of the electron, and this mass is small. Okay, so it has a small mass, and therefore he conclude that this electron is scattered throughout an atom. So they don't have the positive charge, the concept of positive charge yet. Then let's go to Ernest Rutherford. So as we know, he's the famous scientist in this time. As he, in his gold foil experiment, he discovered proton. So he is the one who discovered proton using the gold foil experiment. So let's go to the gold foil experiment. This one class is the gold foil experiment of Ernest Rutherford. So as you can see, these small dots or the violet dots or circle is the alpha particles, which is heavily positive. So when this one is near at the nucleus, or at the center, they don't have a name yet. So this one is repulsed or pushed away by this matter or particle inside of an atom. Therefore, he concluded, Ernest Rutherford, it has a positive charge also in the atom. So now, we have the concept of proton and electron. And with this experiment also, he concluded that electron and proton are equal in numbers. Therefore, it is called neutral atoms. Okay. So the biggest question of his time is when they weighed the mass of the helium and the hydrogen. So with this concept, proton and electron, when you add it, that will be the mass of an atom. However, when they compare the mass of the helium and the mass of hydrogen, it is not equal. So their concept, which means that the atom of the helium will be also equal with the two atom of hydrogen. As you can see that electron and proton are equal. But this, it doesn't make sense. So therefore, another scientist paved his way in this discovery, which is James Chadwick. So James Chadwick discovered neutron. So he is the one who discovered the neutron, which is now the mass number or the atomic mass of an atom. Okay, so with this, they concluded that the neutron and the proton make up the mass of an atom. So let's discuss a short discussion about the experiment. So with this class, he used beryllium, Ernest Rutherford used gold, but here James used beryllium. And also he used alpha particles, and these alpha particles strike in this beryllium and emitted a strong energy or a high energy emission, and they don't know it yet. And then when this pass through in the paraffin wax, it displaces the proton particle and detected by this detector, and therefore they concluded and named it as, in this one, as a neutron, meaning it has a neutral charge. Okay, that is why it displaces other protons here, or the protons here in the paraffin wax. With this, to the experiment, now we know that protons and electrons are equal in numbers, and which is called neutral atoms. And remember, all atoms are neutral atoms. Okay? In all of the periodic table, everything here are neutral atoms. And then, in the experiment also, protons and neutrons have the same size. And then, we also understand that the atomic mass is affected by the neutron and not by the electron, as the previous idea. Okay. Why? As they discovered by J.J. Thomson that electrons has a small mass. Therefore, protons and neutrons is the atomic mass of an atom. So these are the charges and the location of the three subatomic particles. Now that we know the three subatomic particles and how it affects the periodic table, now let's know the atomic number. So as I've said a while ago, the game is they ask the atomic number and the element which attributes with it. So which is why atomic number is the equal number of protons. So all of these class are arranged in the number of protons. So the atomic number is the number of protons in the nucleus. So this is the key information. We have atomic number and other properties, chemical and physical properties of an element, and then the oxidation state and the density. Some they don't include it, but some include it. So we have here average atomic mass. So this is the one that we will discuss. Okay, so which is the correct term? Atomic weight or atomic mass? Okay, so the differences between these is because of the advancement of technology. As we know, atomic weight is affected by gravity or by the term weight, which is misleading because weight is affected by gravity and mass it is not affected by gravity. Therefore, now that we are in this technological age, the term must be atomic mass. Okay, so what is the difference between the average atomic mass here in our periodic table, which is also written as atomic weight, okay, and the mass number? So average atomic mass are all the mass of an atom with different isotopes. And what is an isotope? So these are elements with the same number of protons but different number of neutrons. And the mass number is the total number of protons plus the neutron of each atom. So you just add the proton and the neutron, and that will be the mass number of each of an atom. So let's have an example. And remember, protons is equal to atomic number, and electrons and protons are equal in number. Okay, now let's have an example. So this is Gian. Gian from Earth. Okay, that is the element, the name of the element Gian. And the mass, okay, the mass number is 70 kilogram. So this one class, the mass number is unique for each atom. So has a mass of 70 kilogram and a 20% of the population. So Gian, the population is composed of 20% of Gian. So you can see a lot of Gian in Earth. And then another Gian from alternate Earth and has a mass of 60 kilogram is occupies 80% of the population. Now, let's multiply it and determine the average atomic mass. So this one is the mass number and then the mass number. And when we compute it, we will find the average atomic mass, which is the atomic mass of Gian from both Earth and the alternate Earth. So when we compute it, 20% times 70 kilogram, and then 80% times 60 kilogram, which is equal to, okay, please compute it. And then write the answer in the chat box. So 20% point. Okay, 0.20 times 70 kilograms plus 0.80 times 60 kilograms. And you will get the average atomic mass. So can you please compute it? So why did I, from the term average, we just divide it by 2. But remember, Gian occupies 20% of the population. We have to include it in doing the average. So we will know how many he is in that population. His weight in that population. Then we just add and then that will be the average atomic mass. Okay, very good, Marwin. So the answer is 62 kilograms. Okay, so that will be the average atomic mass of Gian. Now let's go to the molecular level. Okay. In molecular level class, we have here 3 isotopes of hydrogen. So as we know, isotopes has the same, the element that has the same proton, the number has, the proton has the same number, and then for the neutron, it has a different number. So we can see here we don't have proton, neutron, and then in the deuterium, we have 1 neutron and then 1 proton. Then we have here tritium, we have 1 proton and then 2 neutron. But we will just use protium and deuterium. So why? Because these 2 hydrogens are present in our atmosphere. As we know, mass number is the total number of proton and neutron. Therefore, our mass number is 1. And then, the abundance of this in the atmosphere is 99.98%. And deuterium has a mass number of 2. As you can see, 1 plus 1 equals 2. And then, its abundance is 0.0156%. And therefore, let's compute for the average atomic mass. 99.98% times 1 plus 0.0156 times 2. So we will get 0.9998 times 1 plus 0.000156 times 2. We just convert the percent to decimal by moving 2 decimal places to the left. So compute, and what is the answer? What will be the average atomic mass? Okay, very good, Yanina. So that will be 1.00112. So we will write it as 1.000112. But when you look at the periodic table, why is it 1.008? Why it is not 1.00112? Because okay, there are other factors that affect this mass number. Okay, so this is just how we compute it in the surface, but when they use experimentation and want to find the accuracy and precision, as we know from the scientists, so we will use 1.07825 and then 2.014102. So when we compute it, it will be like this. Okay. So when we compute it, class, so okay, 99.98% times 1.007825 plus 0.0156 times 2.014102 will have an average atomic mass of 1.0079, and approximately when you round it off to the nearest thousands, then you will get a 1.008, which is what you can see in our periodic table of here the atomic weight, which is written, but we will use the term average atomic mass. Okay, so this is how atomic mass is computed. Okay, do you have any questions so far about the average atomic mass and the mass number? Thumbs up if you don't have any question. Okay, so now let's move and apply this. So let's apply this one. So let's just have to remember that protons and atomic number are equal, electrons and protons are equal, and when you add protons and neutrons, that will equate or equal to the mass number. Okay, so now let's try this oxygen. So when we put 8 protons here, 1, 2, as you can see and observe, when we add proton, the element is changing. It's because the number of proton is the atomic number and it is the identity of an element. So the proton. Lithium, beryllium, boron, carbon, then we have nitrogen, and then we have oxygen. Why it has an ionic charge? Teacher, you said it is neutral atom because we did not put the electron. So when we put the electron, remember that oxygen, proton is equal to proton is equal to electron. So when we write it down, okay, so we have 8 electrons. So let's add electron here. 2, 3, 4, 5, 6. Okay, there we go. So now we have a neutral atom. So that is why it's called neutral atom. And then we have the number, atomic number, as we know, written here. We have 8. And then the mass number, you can look it at your periodic table. You just rounded it off to whole number, the atomic mass, mass number of oxygen. So we have 15.99, which is 16. And therefore, 16 minus 8, which is our proton, and we will get a number of neutrons, which is 8. Now, let's try for bromine. So, this is a lot of protons and neutrons, so I will not add it. I'll try. Okay, it is until neon. Okay, so 35, and this one is equal to also to protons, 35, and the number of protons is also equal to electrons. And then, with that, you will look at your periodic table. Bromine, we have 79.91. So you will write 80, rounded it off to whole number, and 80 minus 35. Write the answer in the chat box. 80 minus 35, that is the number of neutrons of bromine. 80 minus 35, you will get what? Okay, very good, Marwin. So, Shermel, so that is correct. So, 45. So, the number of neutrons is 45. Now, let's have an activity. You have to complete the missing part of the table. Oh, sorry. Okay. So, do you have any questions and clarification?